Here is lesson 4.7. We're going to talk about the law of sines and cosines. We are going to now look at sides and angles of oblique triangles. So we're going to come out of the right triangle and look at different types of triangles. So here is the law of sines. Now, the law of sines, I'll highlight and write it a little bigger for you. It basically says that the sine of angle A over side A will always equal the sine of B over side B, will always equal the sine of angle C over side C. Remember that A is a pair, B is an opposite pair, C is an opposite pair. You must have opposite pairs in order to find, or to use, the law of sines. You must have at least one set of opposite pairs in order to use this formula. You want to use this formula when you can. It's a pretty straightforward formula. It gives you mathematical proportions, and it would be something that isn't super hard to find. Just make sure that you have the pairs set up right. So you'll notice like that in this particular case, they've used capital letters for the angles. They use the lowercase letter for the sides. So set yours up the same way, and you shouldn't have a problem using that formula. So now let's look at an example using the law of sines. So if you take a look at this problem, we are given a triangle, and it says the good old words to solve the triangle. Meaning, solve the triangle tells us look for any missing angles or sides. Now, this is not a right triangle, so we cannot use the law of Pythagorean. We can't use the Pythagorean theorem. We can't use any of the SOHCAHTOA information. So we have to have other alternatives. So here's where the law of sines is going to help us. Now, one thing we can do is our angle N here is a missing angle, and we all know the other two. So angle N would be 180 minus 29 and minus 112. So angle N is 39 degrees. So you can use your 180 rule. All triangles, whether they are right or not, can follow that rule. So we can't use SOHCAHTOA to find any of the missing sides. We can't use Pythagorean. Those only work for right triangles. So now we're going to use the law of sines instead. You might notice that we have a pair, meaning an angle and the side opposite that angle. That's the only time we can use the law of sines. So now we know that the sine of 29 over 22 will help us to find information about, let's go with M. So M will be found by doing the sine of 112 over M. Now that is a mathematical proportion. It's a very simple thing to solve. All you need to do is cross multiply and then divide. So it's a very simple procedure. So you would do the sine of 112 times 22 and divide it by the sine of 29. When you do that, rounding to the nearest tenth like they told us, M is approximately 42.1. Now, we can reuse that pair that they originally gave us to find the other side. So this time the sine of 29 over 22 can help us to determine that pair, which is the sine of that 39 degrees we found. That's 39 right there, over N. So now we would cross multiply those two and divide by the sine of 29. They're very easy to solve. The main thing to remember is to make sure that your if your input is degrees, that you have your calculator set in degree mode. So here we find that n is approximately 42.1. No, I'm sorry. N is 28.6. I wrote down the number from before. Sorry about that. N is 28.6. Now, a real quick check that can kind of tell you if you were on the right track. Our smallest angle is 29. It should be across from the smallest side, 22. It is. Our medium angle, 39, should be across from our medium side, 28.6. It is. Our largest angle, 112, should be across from our largest side, 42.1. It is. So by just looking at that relationship, you can pretty much check your work pretty quickly. Because if you mess something up, it will probably show up in that light. It won't work out the way that I just said. So there is example 1. Here is another example using the law of sines. Now let's figure out why we're using the law of sines. So we've got these two buildings, and let's assume they're identical buildings, same height. They're across from each other. And there's a balloon between the buildings. When one person looks up, they look up and the balloon has an angle of elevation of 62 degrees above it. We're going to call that angle Y, so that would be side Y. And then another person in the opposite building looks up and their angle of elevation is 49, so it's going to be angle X across from X. We know that the two buildings are 650 feet apart. The question is what is the distance from each building up to the hot air balloon? So we just want to solve for X and Y. Now, in order for us to use the law of sines, we must have a pair. We don't currently have one, but it's going to be really easy for us to find one. So the first thing we have to do is find angle Z. So we know that a triangle totally measures 180 degrees for the angles. So if we take off the 62 that's in the one spot and the 49 that's in the other spot, we find that angle Z is 69 degrees. So let's put that in there. Once we know that, we have a pair. We have an angle and its opposite side pair. We've got this pair right there. So now we are allowed to use the law of sines. So I know that the sine of 69 over 650 should equal the sine of, let's go with X, which is 49 over X. Now again, to solve this, we are going to cross multiply, then divide. So sine of 49 times 650 divided by the sine of 69 will give us X. And X happens to be 525.5 feet. Now we're going to have to use the same setup in a way to find our missing Y value. We're going to use the same pair that we used from the start, the sine of 69 over 650 equals the sine of 62 over Y. Same idea to solve, cross multiply, then divide. So mathematically speaking, we would have 650 times the sine of 62 divided by the sine of 69. And we would find that Y is 614.7 feet. Now again, check yourself. Our smallest angle, 49, is across from the smallest side, 525. Our medium angle, 62, is across from our medium side, 614. Our largest angle, 69, is across from our largest side, 650. So just by taking that second to check that, you are more likely to find if you maybe set something up in the wrong spots or maybe mixed up your setup. So that's how you use the law of sines. If you are not given an angle and side pair, an opposite angle and side pair, you cannot use the law of sines. So then we need a different formula, and that formula is the law of cosines. So let's talk about how we use it. Now, most people remember and memorize the third one pretty easily. Does anybody recognize what it kind of looks like? What does that third formula kind of look like? They look like the Pythagorean theorem. So it's really kind of easy to memorize that third one. Let me write that down. Now, this formula actually does work for a right triangle. That back piece, this negative 2ab cosine of c that you don't usually see in a right triangle, becomes 0. So then you get the Pythagorean theorem. So this formula works for any triangle. We tend to just use it for non-right triangles because we know so much about right triangles. The thing that you want to notice is that these front side match the angle in the back. These ones are found inside of that. These ones are found inside of there. Okay, so the front and the back match, and the other two sides are inside the formula. That's just kind of a good pattern to think about. So here you'll notice our angle C and our side C go together. You see A here and in there. You say B here and in there, okay? And that will always kind of work out. These two are the other sides. These two are the other sides. These two are an opposite pair, okay? Now, the law of cosines is nice because we don't have to have a completed set of an opposite and its angle. So you can use this in many different cases. So that's why the law of cosines is so important. And so let's take a look at how you actually use it. So let's say that we are looking at a lawn. And one little section of the lawn kind of made a triangle. So let's assume it's, you know, a chunk between like maybe a driveway and a house or whatever. So there's this chunk that's a triangular shape. And we want to know some angular measures, but all the guy did when they went out to look at the property was measure the sides. So let's draw a triangle. Now this triangle is not to scale. This triangle is kind of just a holder of my information. They told me that A was 19, B was 24.3, and C was 21.8. And we want to know what angle of sweep should each sprinkler be set to cover. So we are really looking for angle A, angle B, angle C. Now, when you don't even know one angle, you are forced to use the law of cosines. I'm going to start out with my C squared. Because again, that was the one I told you that you want to get in your memory banks. Okay, now let's plug our information in that we know. C is 21.8, so that's 21.8 squared equals 19 squared plus 24.3 squared minus 19 minus 2 times 19 times 24.3 times the cosine of C. I kind of ran out of room, but it would be right there. Okay. Now, here's where most people will kind of set that initial thing up correct, but they will not execute it in a correct fashion. You must follow order of operations. So, these things are all stuck together. It is a coefficient. Negative 2 times 19 times 24.3 is a coefficient on a variable cosine of x. So we can't combine it with anything else. these things have no variable. So they are like terms. So we can get all the things in yellow in one place, and all the things are not yellow we can leave alone. You have to do that in order to solve this problem correctly. Now, for room's sake, I'm going to take 21.8 squared. I'm going to minus off the 19 squared. I'm going to minus off the 24.3 squared. And I get negative 476.25. Now, all the things I've highlighted in blue, I'm going to multiply that. So negative 2 times 19 times 24.3 is negative 923.4. And then we've got that cosine of C stuck on there. Now, we need to get cosine of C by itself. So we're going to divide both sides by 923.4. So we're going to get negative 476.25 divided by negative 923.4. And we should get that the cosine of C is 0.05158. Now you should probably go out minimum 4 decimal places for accuracy. Now, we're looking for an angle measure. So you have to remember that is the time when we are using our calculator where we have to press the second button. You have to find the inverse or the arc cosine. And so we would take the inverse cosine of 0.5158 to find the angle measure that provided that. When rounded to the nearest degree, that's 59 degrees. Okay? Next, we now have a completed pair because we know angle C is 59 degrees. Since we have that completed pair, we can now use the law of sines on the next step. So if you don't have to keep going and do the law of cosines again, why? It's harder than the law of sines. So now we've got this completed pair. Let's use that to help us find, let's go with angle A. So I know that the sine of 59 over 21.8, the pair we know, will help us find a piece of the pair we don't know. So the sine of A over 19. Now, this is an angle we are looking for. So again, you're going to press the sine button on your calculator. We're going to cross multiply and then divide. So we get a decimal value for the sine of A. So the sine of 59 times 19 divided by 21.8 results in the decimal 0.7471. Now that's what the sine is equal to. So for us to reverse that, we have to inverse the sine or arc sine. We do that on the calculator. You have to press the second button, the inverse button, before you actually find it. So A is 48 degrees. Now once you've found your second angle, you can just use your 180 rule. So angle B is going to be 180 minus 59 minus 48. So angle B is 73 degrees. And then we have every angle they wanted. So, angle A should sweep 48 degrees for the sprinkler. Angle B is 73 and angle C 59. So there's an example of how you would use the law of cosines. Let's look at one more example with the law of cosines. Now, in this particular example, we are missing one side and two angles, and we do not have a finished pair. You'll notice this pair we're missing an angle, this pair we're missing an angle, this pair we're missing a side. So we have no completed angle side pairs. So we can't use the law of sines. We must use the law of cosines. Now, since I'm given angle A to start with, I must use the formula that contains angle A. So that would be A squared, the other two added together, minus 2 times the other two, with the angle cosine on the end. Okay? So that's the formula I'm forced to use. So now let's go ahead and let's fill in what we know. So a squared equals 12 squared plus 14 squared minus 2 times 12 times 14 times the cosine of 39 degrees. Sorry, I ran out of room there a little bit. That says cosine of 39 on the end there. What's really nice about this way, when you have the angle, the order of operations is not as much of a problem as it was before. It's just not. It works out a little nicer, okay? So we get a squared equals, let me throw that into my calculator here. And we find that a squared is 79. And so a is the square root of that. And if we square root that, you get, rounded to the nearest tenth, 8.9. Now, we have finally a finished pair. We just found A, and they gave us angle A to start. So now we can use the law of sines to find B or C. Let's go with B. We'll just go alphabetically here. So I know that the sine of angle A over little a is the sine of angle B over little b. Now this time our variable is stuck inside of a sine, so we're going to cross multiply and then divide. So the sine of 39 times 12 divided by 8.9 is 0.8485 is the sine of B. To find B, you're going to inverse sign that decimal. So you're going to second sign on most calculators of that decimal 0.8485, and it's approximately 58 degrees. Now angle C is nice because for angle C we can just use our 180 rule. So angle C is 180 minus 39 minus 58, which is 83 degrees. And then just look, our smallest side, 8.9, is across from our littlest angle, 39. Our medium side, 12, is across from our medium angle, 58. Our largest side, 14, is across from our largest angle, 83. So that's just a really super quick check. The last thing I want to talk about in this lesson is Herons' formula. Herons' formula is a really cool way for us to find the area of a triangle if you know the three sides. You don't have to know a base and a height. So you just know all three sides of the triangle. So you might not have ever seen this before. Step one is we are going to find this S value, which I'll write it down here a little bigger. It's 1/2 the sum of all the sides. That's your first step. Step two, we use the area formula, which is the square root of S times S minus A times S minus B times S minus C. And make sure that you find that whole entire thing before you square root it, so that it is the square root of that entire product. So just watch the way that you enter that into your calculator. Parentheses would probably be your friend. And then let's look at our last example where we're going to use Herons' formula. Okay? So They wanted the area of the triangle. They did not give us a base and a height. They didn't give us really a lot of information to find it. So they did give us 3 sides, and we can apply Herons' formula. So the first thing you want to find is S, which is 1/2 A plus B plus C, which is 1/2 47 plus 53 plus 44. Just make sure you add those all up, get a sum, and then divide it by 2. In this particular case, the answer for S is 72. Once you find S, you can then put it into your area formula. The area is the square root of S times S minus A times S minus B times S minus C. So let's do that. So that's going to be 72 times 72 minus 47 times 72 minus 53 times 72 minus 44. So that's kind of your initial sort of plugging into the area formula. We get the large square root value is 957,600. We got to actually square root that. Again, I would probably go to the nearest tenth. So that's 978.6 square feet. Remember, your units for area, since all of the side units were feet, would be square feet. So that is Herons' formula. Here is the homework for this lesson. Problems 1, 2, 3, 4, and 7 are all utilizing the law of sines. Problem 27, 28, 29 are going to allow you to have to use the law of cosines.
Cosines are really complicated.
Yes, so the c squared equals a squared plus b squared minus 2ab cosine c. And then 37, 38, and 52 are Herons' formula. Be careful of the way that they have broken down the sides in 52. Like this is the 34 they're talking about. This is 43.2. They have broken up each individual side and piece, okay? So that is the homework.